Energy conversions. In this video, we will review the concept of energy conversions and learn how to draw energy conversion diagrams. Let's review. Energy is the ability to do work. When work is done, one form of energy is turned into another form of energy. This is called energy transformation or energy conversion. Energy transfer diagrams are a great way to illustrate the different forms of energy and how they are converted in a situation. So let's take this example. Here we have a diver. The diver is standing on top of a high platform. The diver jumps. So how do you think the energy in this system is going to change as the diver moves towards the water? Well, let's consider the types of energy that are involved. Because the diver is standing on the top, high above the ground, gravitational potential energy is involved. And because when the diver jumps, he's moving, then kinetic energy is involved. So we have kinetic energy, gravitational potential energy, and then we have the total amount of energy in the system. The total energy needs to equal 100%. Therefore, in our energy graphs, you can see that each one has a total of 100%. Let's take the diver at position number 1. At position number 1, the diver is not moving, and therefore the diver has 100% gravitational potential energy. So we're going to go ahead and draw this graph with a line that matches the same height as the total. Now, at position number 2, we see that the diver has the gravitational potential energy has decreased because he's not at the top now, and he has some speed. So let's go ahead and illustrate that at position number 2 in the graph. So at position number 2, he has less gravitational potential energy. So we're going to draw the bar not to. Now remember that at each position, 100% of the energy has to be accounted for. So now let's think about how much kinetic energy the diver has. Well, if I said that the gravitational potential energy, I drew right up to the top here, that means that this much right here is the kinetic energy. So I'm going to draw a bar about that same size. Now let's look at position number 3. At position number 3, we notice that he is right in the middle. So therefore, he is equal distance from the top as he is to the bottom. Therefore, we can think of this as his gravitational potential energy is about 50%. And his kinetic energy is 50% because he's right in the middle. Now let's look at position number 4. Position number 4, his gravitational potential energy continues to decrease. So you can see the energy bars are going down. So let's go ahead and draw his gravitational potential energy as being closer to the ground here, or to the water. And that gravitational potential energy was not lost, but converted into kinetic energy. Now remember, we want to make sure that we account for 100% of the total amount of energy, so we need to draw the potential energy bar about this big. At position number 5, all of the gravitational potential energy has been converted into kinetic energy as he enters the water. Therefore, we are going to draw the kinetic energy bar equal to the total. So if we look carefully at our energy conversion graph, you will notice that as gravitational potential energy decreased, that the kinetic energy increased. Here's another example, the pendulum. The pendulum swings back and forth, just like you swinging on the swings at the playground. In this example, and when you're swinging on the swings, you have both kinetic energy and gravitational potential energy, and they are converting or transforming one into the other each time you swing back and forth. Let's take a look at the amount of energy and how it transforms from one to the next. At position number 1, you are the highest in the front upswing. So you have 100% gravitational energy. So we're going to go ahead and draw this up to the top like this. As you start to come down, so if we look at position number 2, it is halfway between at the highest point and the ground. So at this point, we have half gravitational energy, potential energy. So we're going to say there's the halfway point. So we're going to draw that up to there. And we're moving, and so the other half of the total amount of energy is the kinetic energy. Now, if you look here at position number 3, we are at the lowest point right here of gravitational potential energy, which means now we're out of gravitational potential energy, and all we have is kinetic energy. So we have 100% kinetic energy. And as the momentum of the swing starts to pull back in the back part of the swing, now if we look at position number 4, we're halfway between the ground and the highest point. So now we have half gravitational potential energy and half kinetic energy. And if you've ever been swinging on the swings, you know that as you start to go in that backswing, you start to slow down. And at position number 5, you have the greatest amount of gravitational energy back to being 100%. And because gravity is involved, once the gravitational potential energy runs out, gravity takes over, and the pendulum starts to swing back in this direction, repeating this same energy conversion back and forth. Great work. Now it is time to review your notes and answer the lesson questions. All right, here are your 2 wrap-up questions. Make sure you use the information in the video to answer them, and then when you're done, put them in your binder so that you can give them to your teacher before you take the mastery check.